Okay, cool. Now we know what constraint is. We know what a bottleneck is. Okay, so let's get more in depth on the theory of constraints. So the theory of constraints is the systematic approach that will focus on those concepts that we just reviewed, right? The concepts of a bottleneck and the concept of constraints, right? So we're looking at it. Actually, it was developed by a mathematician. We're going to look at the theories that we just talked about and see how they apply and how can we improve our capacity of our process. Okay, this is another very simple example of a bottleneck. Whenever we have traffic, let's say there's an accident in one of our highways here, I-26, I-20, or there was a roadblock because they're doing construction, right? They're doing a lot of construction. I-26, for example. I live here in Irmo, but in the Lexington side, a lot of construction going on, I-20 and 26. So what happened when you have a lane that is being blocked, right? So in this case, the capacity here is going to be 6 cars, every 2 here. And then in this part, we're constraining it to 4 cars. Oh, what's going to happen is you're going to create a big queue here. A lot of cars are going to be on traffic, and that will increase because this bottleneck is limiting the flow of cars, right? And we know that after we pass this bottleneck, well, life is going to be great again, right? So you're going to have a lot of space and you have a lot more capacity actually that you can use because you only have the 4 cars coming in. So this is the flow coming in, and it doesn't matter if you have a lot of capacity here. You're not gonna save the time that you lost here, right? So the same thing happened on malfunction junction. Do you guys know what malfunction junction is? So, if you come here to the suburbs, you can go out to Columbia basically one way, and then you have 26 coming, and then you have 20 that is going this way, and it's all a mess because everybody wants to go that way, and then you have 2 highways, kind of, 6 lanes becoming 3, and it's always gonna be a mess when that happened, right? So about 4:30, if I live at the university at 4:30 until 6, it's a mess. It takes 40 minutes to get home. If I live before that or after that, it'll take 22 minutes to get home. So how does that impact our decision? So here is the 5 steps for the theory of constraints. First thing, identify the bottleneck. So look at my processes and find out which one is going to limit my capacity, which one is the slowest process that will produce less amount of parts. Okay, the one that produced less amount of parts is going to be the bottleneck. So after I know that, okay, I can make sure that I'm looking at that bottleneck and making sure that that bottleneck is producing as much as it can, right? So I'm gonna do the step 2 and 3, which is looking at all my decisions and see how can I make the bottleneck more productive. How can I can lose time in the other steps, but the bottleneck have to be protected. What different sequency, what different parts should be produced in order to maximize that bottleneck, and so forth, so on. Number 4 is to elevate the bottleneck. So what does that mean? Well, I'm going to try to produce more with my bottleneck, and that could be just finding ways to reduce the cycle time, so I produce more, or putting more resources. Maybe I need to put another operator there. It will produce with a higher volume, and maybe I can put another equipment there, so again will produce more parts. So it's all about trying to produce more with that process step. Okay. And finally, number 5 is okay, I need to come back to number 1, right? So after I'm producing more with that step, after I elevated the bottleneck, which is number 4, I need to go back to number 1 because now I can have another, maybe I have another bottleneck. Maybe it's not that one anymore. Maybe another one became the slowest one, and then I need to start over again. So it's like a continuous improvement where you're going back and forth, looking and finding out and managing your system according to the production of the bottleneck. Okay. And we're going to do some problems that are going to help you guys understand those concepts. Here we have some principles of bottleneck. I'm not going to read each one of them. You guys can read it more carefully. But basically, you're trying to balance the flow of the products, maximize the efficiency of the whole system. We're going to talk about productivity in bottlenecks and non-bottlenecks activities as well. And yeah, and then you guys can read to that. But so it's important to understand kind of this overall concept, and then we're going to look at some practice examples and see how that apply.